Well, this is where life is going to get fun. These are irrational square roots, and we are working in lesson 11.4. Irrational numbers are numbers that do not terminate or repeat. So we're going to learn how to split up square roots. Our essential question says, can you simplify radicals and find decimal approximations of irrational square roots? So we're not going to work with the decimal approximations, but we are going to remember that they told us if we have a times b, we can split it up as the square root of a times the square root of b. Let me say that again. The square root of a times b is equal to the square root of a times the square root of b. And what they want us to see is that, like 216, well, if I put that in my calculator under a square root, I get 14.696938. That doesn't work out. But I do know that if I go ahead and multiply it by 36, well, 36 times 6 is 216. Now, I know that because I've probably been doing math a little bit longer than you. So I also know that the perfect square of 36 is 6. The root 6 is going to stay under. So we're learning how to take these square roots and simplify them. The answer to this square root is 6 times the square root of 6. Now, let's look at this one. Anything with a, if you think about quarters, like 125, quarters can go into 125. How many quarters go into 125? Good, we can do 5. So this is saying 3 times, 25 times 5 is 125. So I'm just going to split those radicals up, knowing that 25 can pop out to be 5. So this 3 is saying 3 times 5 root 5, which is 15 root 5. So notice we're just taking the square root, breaking it down to our perfect squares. This is why your math teacher made you memorize your perfect squares, and writing them as a simplified radical. All right, moving on, the square root of 1920. Well, I didn't know this one. I actually had to mess around with my calculator with this. Well, I now know, because I was playing around, that 64 and 30 multiply to be 1920. So actually with my calculator, I just put in all those perfect squares that I memorized. So I knew that 64 was a perfect square. Thought, hey, maybe that could work out. 64 is a perfect square. I know that can come out and be 8 and root 30. Now remember, 30 almost seems like something can come out because 3 and 10 and 5 and 6, but none of those are perfect squares. So there is no perfect square that divides. Oh, we also have 215. There's no perfect square that divides into the square root of 30. And that's why we break it down like that, because we only can do the perfect squares. All right. Well, this one's kind of fun. We do have to have some information about the nearest 10th place. So in my calculator, I'm just going to take the square root of 637. Remember, the square root is second, and it's above the x squared. And when I do that, I get, sorry, I need a pen. I get 25.2388, ... But it tells us to round to the nearest 10th. Well, the 10th place is the first one, so I believe this is just 25.2. To end, I'm going to put these up because these are the most common problems. So if you would like to push pause, I am going to go through all of these examples to show you how to break down these radicals. These are very common, probably by Algebra 2, you'll know how to do these right in your noggin. So if you want to push pause and do these, push pause now. If not, I'm going over them. 18 can break up to be 9 and 2. We know the square root of 9 is 3. 3 root 2 is the square root of 18. 20 can break up to be 4 and 5, where 4 is the perfect square, and I get 2 root 5. And 75 can break up to be 25, always think quarters, I'm having trouble seeing that. 25 and 3. 25 can pop out to be 5 root 3. These are very, very common. Notice I answered all of them as radicals and none of them as decimals, so we always want to reduce in the lowest radical form. Great job.